All right, now let's take a look at section 4.1. The first part is just going to be a bunch of words that we're going to need to know, okay, and what they mean. They're definitions, kind of definitions. I'm not going to like make you write out a definition. Have I ever had on a quiz or a test make you write out a definition for a word or something? No. I think the only thing I actually had you write down was like, what are the 3 undefined terms, right? And what are they? What are 3 undefined terms? Point, line, and plane, right? That's really the only time I've actually made you like memorize something and write it down, right? This is kind of the same thing. I'm not going to make you memorize it and write it down, but you're going to have to know what they mean because we're going to refer to this quite a bit. All right, I got some triangles over here. Let's see. Nah, I'll just draw it myself. All right, here we go. So we've got a triangle here, here, and here. All right. Now, what I want to do is there's 3 types of triangles according to their angles. All right, so 3 types of triangles. I'll shorten triangle to look like that. And in parentheses, I'm going to put because of their angles. So what I'm doing is I'm looking at this triangle and I'm only looking at the angles. See the angles right here, here, and here? What type of angles are in this triangle? Like what kind of angle is that right there? Now, I don't know how many degrees it is exactly, but I know a couple types of angles. Remember acute, obtuse, right? Remember that stuff? Okay. So what kind of angle is this one? Is this one and this one? They're all acute, aren't they? Okay, they're all acute angles. So all acute angles. So in order to see what type of triangle this is, if they're all acute angles, take a wild guess on what kind of triangle we're going to call this thing. An acute triangle. Very good. So this is called an acute triangle. Why? Because all the angles are what? Acute. Okay? They're all less than 90. That's what acute is. Okay? They're smaller than 90. Every one of these angles, you can just kind of look at it and see, they're all less than 90 degrees. So if all 3 of them, all 3 angles are acute, then it's an acute triangle. Everybody with me? Yeah, that's not so hard. Easy start to the year. All right, let's do this. Now, is this an acute triangle? No, because now that's an acute angle right there. That's less than 90. That's an acute angle right there. But what kind of angle is this? This is an obtuse angle. So an obtuse triangle, are all 3 angles obtuse? No. How many? Just one. So if I have one obtuse angle, then I call this triangle an obtuse triangle. It's not hard to see, is it? All right, so that's an obtuse triangle. Why can I not have, or can I? I haven't said it yet, but can I have 2 obtuse? Watch. Let's, okay, there's an obtuse angle. Can I draw another obtuse angle and still have a triangle? No, because look, if I draw another obtuse, is there any way I can get a triangle out of that? Not, because I'm getting further and further away from this, aren't I? All right, so there's no way I could have 2 obtuse triangles. Agreed? Okay, so an obtuse triangle means I only have how many obtuse angles? 1 obtuse angle. All right, good. Let's do another one. What do you think this looks like? A right angle. Good. So what do you think I'm going to call that triangle? A right triangle. Now, do I know right now with that picture that that's a right angle? No. What do I need to put there? A little square, a little box. Okay? Put a little box right there, a little square right there. Now that means that's a right angle. How many degrees is a right angle? 90 degrees. Okay? So what do you think I call this triangle? A right triangle. So I call it a right triangle. How many 90 degrees angles can I have in there? Just one. Okay? I can only have one right angle. Kind of the same reason that we did before, but let's just try to draw one with 2. So watch. Pull that down a little bit. Okay? So check this out. What if I wanted to draw another right angle? What would happen? It would just go up like this. Is there any way I can make a triangle out of those 3 sides if I have 2 right angles? No, there's no way, right? There's no way I can connect to there if that's a right angle. Okay, so there's no way I can have more than 1 right angle. Okay, so I can only have 1 right angle in a triangle. I can only have 1 obtuse angle in a triangle, but I can have what? 3 acute angles in a triangle. Everybody good? Yeah. All right. Now, there's another way to name some triangles. This one, we named them by their angles. All right, we looked at all the angles. Oh, let me do this. This obtuse triangle, it has 1 obtuse angle, but what kind of angle is this one up here? It's acute and acute. So this still has 2 acute angles. Does that mean it's an acute triangle? No, all 3 of them have to be acute. What about this right angle? What's true about this angle here and this angle here? They're acute as well. Does that mean it's an acute triangle? No, because we have a right angle. Everybody got that? So in order to be an acute triangle, all 3 have to be acute. All right, make sure I wanted to say that. Now what we're going to do is we're going to look at the triangles. Instead of looking at the angles, what do you think we're going to look at next? At the lengths of their, say it? The lengths of their sides. The lengths of their sides. Very good. All right, so now we're going to look at 3 types of triangles. 3 types of triangles. But this time, we're not looking at the angles. We're looking at the sides, at the lengths of the sides. All right, so I'm going to try to draw it. And okay, so let's say, come on, there we go. Let's say that that's got 1 tick mark, that's got 2 tick marks, and that's got 3 tick marks. What does that tell you about the lengths of the sides? They're all the same? That has 1, that has 2, that has 3? It means they're all different. If they all had 1 tick mark, what would that mean? They're the same. But when they all have a different number of tick marks, that means every length is different. Would you agree? So none of these are the same. All right? This might be 3, this might be 4, this might be 5. Let's just say that. Okay? Okay, so what if you had that? What kind of a triangle do we call this? This is a name that you probably have not heard before. We've heard acute, we've heard obtuse, we've heard right. This one you probably haven't heard before. So if none of the sides are equal, so I'm going to write no sides are equal. All right, everybody see that? None of the sides are equal. We call this a scalene triangle. Not a word that you're probably familiar with, but that's what we call it. We really don't do too much with scalene triangles, okay? So it's nice to know, I guess, but we don't do a ton of stuff with a scalene triangle. All right, but when none of the sides are equal to each other, we call it what? Scalene. Very good. All right, get the idea of what we're doing? We're looking at the lengths of the sides of the triangle. All right, so let's do another one. Let's do this. Let's do this and this. All right. So now, what if I did this? What if I said, that's got 1 tick mark, and that's got 1 tick mark? What does that tell us about those 2 sides? That they're equal. So how many equal sides do I have on that triangle? I got 2 sides that are equal. Okay? And we give that a name. This might be something that you've heard before. My guess is maybe in middle school math, you talked about this a little bit. Does anybody know off the top of their head if 2 sides are equal what it's called? That's okay. We call it an isosceles triangle. Isosceles. Anybody heard that word before? Isosceles? Yep. It's a fairly common word, especially in geometry. In geometry, it's a very common word. But even in math, you might have heard that word before. Let's try to spell it correctly. All right? It's kind of a little pet peeve of mine, spelling. But let's break it down into 2 words. Look, what I do, if I was to spell it, I would do the isos first. Pretty easy to spell. I-S-O-S. Okay? What you might want to do is write this down 5 or 6 times just so you remember how to spell it. All right? I'm not going to do that, but you could do that on your own. So it's isos, and then what's this part? How do I say that? Celes. But the S at the beginning is a C. All right? Like Celine Dion. Have you ever heard of Celine Dion? She used to be a famous singer. She's not so famous anymore. But anyway, her name starts with a C, right? There's a lady on Channel 6 News. Her name is Cecily. But does it start with an S? No, it starts with a C. C-E-L, all right? So it's a Celes, C-E-L-E-S. So isos, Celes. Everybody write it down? Okay. Practice writing it down a few times so you spell it right. Isosceles, all right? That's how you say it, okay? And it's an isosceles triangle. So when 2 sides are equal, we call it an isosceles triangle. So what do you think the next thing is? 3 sides. That's right. Okay, and oops. Let's use this thing. Just so I make it perfect. So that made it perfect. All 3 sides are equal. So if I put 1 tick mark here, this one's equal, so I put 1 there. And this one right here is equal to it, so I put 1 right there. Okay? Everybody see that? So when all 3 sides are equal to each other, we give that a name. We call it equilateral. Have we used that word before? Can't remember. Equilateral. Of course, E-Q-U-I, what word do you see in there? Equal. That's right. Lateral. We've talked about lateral before. What does lateral mean? It means the sides. Remember, if you do basketball, coach blows the whistle. Even football, you might do this, right? He's got a ball out there, he blows the whistle, and he moves the ball this way, he moves the ball this way. You ever do that? Okay? And you like shuffle from side to side. They call that the lateral drill, okay? Because you're going side to side. So lateral means sides. So equilateral, the same sides. That's literally what that word means, okay? When all the sides are equal to each other, then we call it an equilateral, what? Triangle. Everybody good? All right. So those are just basic words that we need to know. And their words are going to show up a lot, not just in this chapter, but throughout the rest of the book. All right. We're going to talk about isosceles triangles, equilateral triangles, and so forth. All right. So keep that stuff in mind. All right. We got another thing to do. And let's just draw the triangle first. Bring it up. Oh, you're going to miss the good part. This is actually the best part of the lesson.
Everything you do is a good part.
Is it? Well, I appreciate that, but this one is the best part. All right, watch what I'm going to do. I'm going to number these angles. This doesn't mean how many degrees it is. It's just the number. It's just the name of the angle. So this is angle 1, angle 2, angle 3. Everybody's watching, right? So what I want to do, and this is something you might already know. I'm curious to see. I think in my last class, not too many people knew this, but I think a couple did. If I was to add up all 3 of these angles, now this could be any triangle. I could have drawn any triangle I wanted to. All right? It could have been equilateral. It could have been obtuse. It could be acute. It could be right. It doesn't matter. All right? Any triangle, if I add up all 3 angles, does anybody know what they would add up to be? Because every triangle, the angles add up to the same number. What is it? 180. Very good. Okay, so 180 degrees. Is that something that anybody told you before? Yeah, I think maybe in middle school they might have told you that kind of stuff. But all 3 of these angles add up to 180. So I could just go on and say, I could just move on and say, all right, all these angles add up to 180 degrees. And then you're like, okay, that's great, but I don't know why. You want me to show you why? Of course. All right, let me show you. Let me put my mic down for a sec. Take a piece of paper out. I'm going to do a little demonstration for you. I think this is kind of interesting. What I'm going to do is I'm going to make a triangle. So I got a piece of paper. It's a rectangle right now. I'm just going to chop it. It doesn't matter. Again, I can make any style of triangle. I'm just cutting off a piece. So that's got a corner on it. So that's a right triangle. But watch what I'm going to do. If I added up this angle, if I was to measure this angle right here, okay, I'm not going to, but if I was to measure this angle, this one up top, and this one down here, what should they add up to if what I was saying earlier was correct? They should add up to 180 degrees, okay? But let me show you visually why they add up to 180 degrees. We learned something. This is kind of like getting ahead of ourselves a little bit, but that's all right. Donnell, you watching this? This is the best part of this whole lesson. All right, so do you remember we've talked in the past about things adding up to 180? What was that? What did we say equals 180 or adds up to 180? Well, we didn't talk about triangles before. Well, that's only under certain situations. That's only when you had two parallel lines cut by transversal. Okay? Again, that's only when you have two parallel lines cut by transversal. Okay? But in general, any two angles that form a what? Straight line. That's right. Any angles. It doesn't have to be two angles. It could be a number of angles. Any angles that add up to be a straight line adds up to what? 180. All right? So watch what I'm going to do here. I'm going to take this angle and I'm just going to rip it off. All right? Everybody see that? So there's one of my angles right there. Agreed? I'll put it down. Here's my second angle. I'm just going to rip that off right there. Everybody see that second angle? And then I got a third angle. That's this one right here. I'm going to rip that one off. Now, this is the corner of a piece of paper, so how many degrees do you think that is? It's 90 degrees, right? But again, this works with any triangle. It doesn't have to be a right triangle. So what I'm going to do is I'm going to take my three angles. There's one of them. There's a second one. If I had three hands, it'd be a lot easier. Here's the third one, okay? Watch what I'm going to do. Everybody watching? Can you see me? I'll put some light on this situation. Watch, I'm going to take this angle. I'm going to put it right next to each other. See that? Now watch, I'm going to take the third angle and put it right here. Basically, I'm adding them all up, right? What does it form? Not a triangle. That's not a triangle. A straight, what? No, that's not a rectangle. Straight line, okay? That just forms a straight line. Would you agree? So if I take one angle, right, I take the second angle and I take the third angle and I put them all together, which means I'm adding them up, right? If I add them all up, it forms what? A straight line. How many degrees is a straight line? It's 180 degrees. So guess what? These three angles add up to be. These three angles add up to be what? 180 degrees. Isn't that kind of cool? Yeah. All right, so that's your reason. If somebody asks you, well, why did the angles add up to 180 degrees? I don't know who's going to ask you that. Maybe I will. All right, but then you can show them why. Here's another way to show you. All right, so what I'm going to do, and you guys kind of referred to two parallel lines cut by a transversal a little earlier, but here's what I think is kind of interesting. This is not something you're going to have to do in your homework. This is just showing you why those three angles, 1, 2, and 3, add up to 180 degrees, okay? That's the only reason why I'm doing this. And I think it's important. I really do. I think it's very important you see why certain things are true. I could stand up here and tell you all kinds of things, and you could just sit there blindly listening to me and like, okay, teacher said it, I guess it's true, all right? But you don't always want to be like that, okay? You want to be a critical thinker. You want to ask the question, why is that true? And so in this situation, I'm going to show you. So I drew that yellow line parallel to the bottom of this triangle. So I'm going to put a parallel symbol right there. Everybody see what I did? Okay, I just arbitrarily drew a parallel line. It's not any old line. It's parallel to this. All right? First of all, let's do this. Let's go 4 and 5. So look at 4, 2, and 5. What do they form? They form a what? 180, which means that it's a straight line, right? Everybody see that? So I could write angle 4 plus angle 2 plus angle 5. Now, you know this already. You knew this before. You know that these three angles add up to make a straight line, which means they must be what? 180 degrees. What am I trying to show? I'm trying to show that angle 1, 2, and 3 add up to 180 degrees. All right, well, let's see what we're going to do. Look at angle 4. Is there any relationship between angle 4 and another angle here? Angle 1. And what are they? Well, they're acute, that's true, but they're parallel lines cut by transversal. This is my transversal. These are my parallel lines. What do they look like? We just finished a chapter on this. Alternate what? Interior angles. That's right. And what's true about alternate interior angles? They're the same. They're equal to each other. So instead of writing angle 4, I could rewrite angle 4 as what? Angle 1. Everybody with me on that? So 4 and 1 are the same measure, right? They're not the same angle, but they're the same measure. So this is angle 1. Angle 2, I'm just going to write down as angle 2. All right, because angle 2 equals angle 2. What else we got? Angle 5 equals what? Angle 3. Angle 5 and 3 are equal to each other. What's the reason? Because they are alternate interior angles as well, right? Parallel lines cut by transversal. So 5 and 3 are the same measure. So instead of writing angle 5, I could write it as what? Angle 3. Now check it out. What did I just do? I just showed you that angle 1 plus angle 2 plus angle 3 equals what? 180 degrees. That's kind of cool, I think. Seems like some of you don't really care that much. That's all right. I think it's kind of neat, and I think some of you do too. So there you go. I just proved to you, okay, I did a thing that in geometry we call a proof. I just proved to you that angle 1, 2, and 3 add up to 180 degrees. It doesn't matter what kind of triangle that I picked. I could have picked a right triangle. I could have picked an obtuse triangle. It doesn't matter. Every single time you have three angles inside of a triangle, they will always, 100% of the time, add up to 180 degrees. Okay? Does that make sense? All right. I think that's kind of interesting. Don't you? Probably not a question I should ask. All right. Yeah, I think it is. Let me go back to, this is a theorem. They call this theorem a corollary. It's kind of a fancy word for, it's another theorem, but it just has to relate to, don't look around, I know it's you, so stop. You think you're so sneaky, but you're not. So a corollary is something, here I'll write it down, corollary. It's basically a theorem. It's a rule. It's something that we can prove. It's just another word for a theorem, okay? Because it has to do with the last theorem that we just talked about. So this is actually a theorem as well. Knowing that all three angles add up to be 180, that's a theorem itself. I don't think I wrote it down, but they call it the triangle angle sum theorem. You don't have to know the name of it. Who cares? But you do need to know that angles 1, 2, and 3 add up to 180. All right, enough of that. Let's move on to this. Here's a right triangle. Tell me something about angle 1 and angle 2. They're both acute. We talked about that earlier. But it's more specifically, we just talked about something. What do they add up to be? No, just 1 and 2. Just 1 and 2. What does angle 1 plus angle 2 equal? How many degrees is this right there? It's 90, okay? What do all three of them do? Okay, so 1 and 2 would add up to 90. That's right. Okay, how did you get that? Yeah. So watch. Let's do the math on it, okay? So angle 1 plus angle 2 plus that 90-degree angle, right, that right angle right there, what do all three of those add up to be? 180. Now, how do I get just 1 and 2 by itself? I got to get rid of that 90. How do I get rid of that 90? Subtract a 90. Okay? So watch what happens. Bring down the angle 1 plus angle 2. What does that equal? 180 minus 90 is 90 degrees. So what does angle 1 and angle 2 do? They add up to be what? 90 degrees. Everybody see that? All right, so anytime you have a right triangle, that's only when you have a right triangle, the other two angles, the acute angles of a right triangle add up to be 90 degrees. Well, we have a word for that. Do you remember what the word was when you had stuff add up to 180? Do you remember what that word was? When you had numbers add up to 180, or angles, two angles that add up to 180. We said those angles were, starts with an S. You got it, supplementary, very good. Okay, but these two don't add up to 180, they add up to what? 90. We have a word for that. And it's very close to supplementary, but instead of supplementary, it's complementary. Okay? So what does it mean for angles to be complementary? What do? They add up to be what? To be 90 degrees. What does supplementary mean? Supplementary means they add up to be 180. Okay? So complementary means they add up to be 90. So our corollary basically says this. The acute angles, angles 1 and 2, they're my acute angles, of a right triangle are what? Complementary. And what does that mean when they say it's complementary? It means these two angles add up to be 90 degrees. That's all it's saying. Does that make sense? Yeah. Let's do probably one more. Let's put an equilateral triangle on here. Okay, so here's an equilateral triangle. Put it right there. What I want, now it's equilateral, which means all what? Three sides are equal to each other. Now, here's something that I haven't told you before, but if you have a triangle when all three sides are equal to each other, what do you think is going to be true about the angles? They're going to be equal to each other as well. Okay? Everybody see that? So when you have all three sides equal, that means all three angles are going to be equal. All right, so that's something a little bit new. Now, what I'm going to ask you this is, how many degrees, okay, what's the measure of this angle and this one and this one? If they're all the same, let's just call it something. Let's call it x. Is that all right? Call that angle x, degrees. What would I call this one? No. If they're all the same, why would I give it a different name? If they're all the same, I'll call this x as well. What am I going to call this one? X degrees. Now, what did we learn on that big theorem that we learned with the triangle? What did we learn about all three angles? Well, okay, they're all acute, but what was the big thing that we learned when I ripped the corners off? They add up to what? To 180. They add up to 180. So, tell me something about all three of these angles. What do? They add up to 180. So let's do this. Let's add them up. So what's x plus x plus x? 3x. So when I add up all three angles, it's 3x. And what should that equal? 180 degrees. Okay? Now, I want to solve for x. I want to find out what x is equal to. What do? You got it. Divide by what? 3. Not 3x, just divide by 3 because I want x to stay there. Divide that by 3. So x is what? 60 degrees. So anytime you have an equilateral triangle, every angle is going to be how much? 60 degrees. It doesn't matter how big, doesn't matter how small. All three angles, when all the sides are equal to each other and all the angles are equal to each other, when that's true, each angle is 60 degrees. Everybody got that? Okay, so that's pretty important. We didn't quite finish this lesson, but listen to me. I do want you to do the homework, all right? And the homework is 1 to 16. But what you're going to have to do, since you guys missed yesterday, you're going to have to put a little extra effort into tonight. So I'm going to teach the lesson. I don't think everybody's listening to me. Listen. I am going to teach the rest of this lesson to the next geometry class after chapel. I'm going to record it, put it on YouTube. What's your job? is to watch it so you know the second part. Once you watch that second part, you should be able to do all of these, okay? So your homework is to watch the video from the other class and then do this homework. So this is due tomorrow. This is due tomorrow. It's on your lesson plan. I gave you a lesson plan earlier today.